Converting moles of a compound to mass. Oh, now we're going to start with, we know how many moles there are. We know how many moles there are, but now we want to find the mass. First, you must calculate the mass. Suppose you need to measure a certain number of moles of a compound for an experiment. First, you must calculate the mass in grams that corresponds to the necessary number of moles. Then, so if you know that 1 mole is 52 grams, then you need to measure out 52 grams to get your 1 mole. Okay. Then that mass can be measured on a balance. For example, in example problem 11-2, you learned how to convert the number of moles of elements to mass using molar mass as the conversion factor. Okay, we've already done those conversions. The procedure is the same for compounds, except that you must first calculate the molar mass of the compound. So when we're doing this with elements, you didn't have to figure out the molar mass of the elements because you could just go to the periodic table. But now when you have a compound, you have to add together all of the masses in the right proportion for each of the atoms that are comprised in that compound. Okay. So the pungent odor of garlic is characteristic of sulfides. Sulfides, including hydrogen sulfide, are noted for their strong, often unpleasant odor. The sulfur atom in allyl sulfide forms a chemical bond to each of the two C3H5 groups in the molecule. Okay, so there are practice problems here for you, okay, that are going to have you take, you can do that. Converting the mass of a compound to moles. Imagine that the experiment you are doing in the laboratory produces 5.55 grams of a compound. How many moles is this? Well, that's going to be a complicated answer, isn't it? To find out, you have to calculate the molar mass of the compound. You have to know what's there and figure out what is the molar mass and determine, and you find out that that happens to be 185 grams per mole. The molar mass relates grams and mole, but this time you need the inverse of the molar mass as the conversion factor, right? We want to know how many moles there are. So we flip it upside down so moles are on top and that ends up over here, right? So we're going to cancel out compounds. And we end up with 0.0297 moles in 5.55 grams of a compound that has 185 grams per mole as the molar mass. Okay. See, ice just said that grams per mole, but remember you can flip this upside down, back and forth, because it's a proportion, right? It's a ratio. So you can turn it upside down to match whatever is over here on the left so that you can cross out. This is on the top and this is on the bottom. Okay. You want the resulting label to be on the top, right? Mole compound, mole compound. Okay. Converting the mass of a compound to the number of particles. Example problem 11.8 illustrated how to find the number of moles of a compound contained in a given mass. Now you will learn how to calculate the number of representative particles, molecules, or formula units contained in a given mass, and in addition, the number of atoms or ions. Recall that no direct conversion is possible between mass and number of particles. You must convert the mass to moles by multiplying by the inverse of molar mass. Then you can, inverse just means turn it upside down, right? Then you can convert moles to the number of representative particles by multiplying by Avogadro's number. To determine numbers of atoms or ions in a compound, you will need the conversion factors that are ratios of the number of atoms or ions in the compound to 1 mole of the compound. These are based on the chemical formula. Okay, so this is going to be more complicated. It's just going to take more steps, right? You're going to have to figure out the molar mass of a compound and then be able to calculate, apparently here it's how many. Oh, you're at the end, you're going to find out how many actual particles there are by using other conversion factors, okay? So it's just a repeat, right? You've got to understand how to put these ratios together, okay? If you're having a problem with that, you need to seek help with that, because this is the key, and you have to just repeat and repeat and repeat this process and know how to get from one place to the next. Moles of atoms or ions, moles of compounds, okay? So you have to convert the moles of atoms or ions to the moles of compounds. You have mass, you have representative particles. So we have all of this going on here, and you're making conversions back and forth and around. Conversions among mass, moles, and the number of particles are summarized in figure 11.8. Refer to this diagram often until you become familiar with the calculations. Note that the molar mass and the inverse of molar mass, 1 mole per the number of grams or the number of grams per 1 mole, are the conversion factors between the mass of a substance and the number of moles of the substance. Avogadro's number and its inverse are the conversion factor between the moles of a substance and the number of representative particles. So if I want to go from a mole to representative particles, I need to know this conversion factor. If I want to go from moles of atoms or ions to moles of a compound, I have to be able to convert those using the compound equation. Where am I? To convert between the number of moles of a compound and the number of moles in atoms or ions contained in the compound, that's what I was just talking about, you need the ratio of moles or atoms or ions to 1 mole of compound, or its inverse, which are shown in the upward and downward arrows here in 11.8. These ratios are derived from the subscripts in the chemical formula. Okay, so this has to do with the subscripts, right, in the chemical formula. That's how you get from the atom ion to the compound. Okay. What ratio will you use to find the moles of hydrogen atoms in 4 moles of water? So I want to find out how many moles of an atom, particular atom, I want to find this out. And I know that I have 4 moles of a compound, water. So now I have to figure out what is the ratio of hydrogen in the compound that makes water, and do the conversion to get to the atoms. Okay? I think that's the end. Hope it helps.